Okay, let's talk about relative standing. What I have here in front of me is ESPN's latest definitive top 10 NBA players of all time. Now, whether you agree or don't agree with the ranking, this is, this was decided by NBA experts, and we're just going to take them for their word. So whether you want to switch LeBron James and Michael Jordan is totally up to you. But this is what ESPN has, and so the way that we have these organized is the number one spot goes to who's deemed the number one basketball player of all time. And then the number two spot is the second greatest player of all time, and so on, until we get down to the 10th spot, which goes to Shaquille O'Neal. Now, the way that we think about rank in this class, in statistics in particular, is we think about arranging our data from least to greatest. So, in other words, even though, we understand what it means to be the 10th position in this list, meaning the least greatest in our list, as we're arranging data, and this is categorical data that we have here, right? But it works also for quantitative data. Then we have to assign rank backwards. It's counterintuitive, but basically what we mean is this would be the first data value in our set. This would be our second, our third, our fourth, our fifth, and so on. So that the very last data value is assigned a rank equal to the sample size. So we're not inverting the preference here. We're not saying, okay, now Michael Jordan's the worst one in this list. We're just saying this is how we assign rank. And rank is really helpful because now we can think about, okay, what does it mean to be above all the other players, right? So the 7th ranked player in this list would be Bill Russell. Okay, so this is good for when we have a nice, easy to understand sample size, right? 10 is a nice number. We know what it means to be 7th best. We know what it means to be 3rd in the list. But what if we had some really random sample size, like 75 or 13? What do we do then? So what we would do then is we would rescale our ranking, and to do so is to assign what we call the percentile rank. So here's how we do that. You take the rank, and we're going to rescale it according to this formula. So the percentile rank is just our rank multiplied by this ratio. 100 divided by n, or our sample size. Percentile rank is not always going to be a whole number, but when we do get a whole number, it'll be nice and easy to understand still. And so if our sample size here is 10, then that means we are going to multiply the rank by 100 divided by 10. In other words, we multiply by 10. Okay? So our whole list, we're going to multiply that by 10. And so we would get 10, 20, 30, 40, 50, and so on. And here's how we want to interpret this. Okay, just zero in on your favorite in the list. Could be anyone. Could be, I don't know. Let's think about Magic Johnson for a second, right? So Magic Johnson is the 5th best NBA player according to this list. That means they are ranked 6 in this data set. And that also means that Magic Johnson is better than or as great as 60% of the data set. So this 60% is really representing something about everyone below whoever is at that spot. Okay, so this has really important implications for when we get to percentile, but percentile rank is still just a way for us to arrange the data values and think about, okay, who's best, who's not as best, but rescaling it so that our very, very last data value, the one that we've deemed as the best or the greatest, has a value of 100. And that means 100% of the data distribution is less than or as great as that data value. So in other words, Michael Jordan is greater than or at least as good as 100% of the people in this list.